I had a bug. I was dividing not by r squared, but 1 over r to the 1/2 power, maybe. It has to do with breaking up components in x and y. Anyway, I fixed it, and the behavior is really cool now. So check this out. Okay, 2 electrons, purple protons. Let's confine these guys. The 2 protons are in the middle. You think they would separate really quickly? Well, they will. I'm slowing down the simulation. Let's speed it up again. Okay, so there we go. So doesn't that look awesome? It's like they're in phase, like a hydrogen molecule or something. And the 2 electrons on the outside are actually keeping the 2 protons closer together, I think, because if I remove these electrons, these 2 protons fly off to different corners and they'll bounce off the corner and never want to interact again. But the electrons are going in this orbit around them, and preventing that from happening is the coolest thing. It's like an emergent behavior here. I'm just going to let this run and play around with the box a little. Let's stop the motion, start it up, see what happens. We can get these things into some really cool states. Now, there's really only 2 electrons. I'm slowing it down, but sometimes it looks like there's more because they move so fast. Like a probability cloud again. We can add some fade, but that doesn't really help. So speed up the simulation. Watch these 2 guys. Close the box. Got some really cool behavior. Slow it down and see what's happening. Look at that as an orbit. The 2 electrons are like, what is it when the electrons are all in a crystallized phase, a superconductive state or something? Like all the electrons are in lock and step with each other? A condensate? I don't know. It's just so cool I can get this with just the behavior of just the basic Coulomb's charge and gravity here. That's all. I'm not even using nuclear forces yet. I plan to add those in a little bit. I've got it all Wikipedia'd, ready to go, but along the way I came across that 1 over r squared bug and I changed it and I was like, oh my gosh. So all the simulations previous to now are basically doing the same behavior, but these are just more symmetrical and they look like what you would expect more. Some of the others, I don't know. It's cool to just play around with the laws of the universe here. So let me add 1 electron and let's see what happens. So now 1 electron, it tends to want to stay in the middle. That's only 1. Let me slow it down so you can see. Now I'll contain the box. Now the purple protons want to just stick on the sides. Oh, there we go. I got it. So why is it going? It always wants to go in the middle. I guess it wants to get pulled equally by both, maybe? That is a cool symmetry. Look at that, a circle in the middle, and 2 protons on the side that just look like they're bouncing without any net force. This is so cool. The gravity and the Coulomb's force between these 2 doesn't seem to affect the 2 protons. They're not seemingly attracted or repelled. I guess because the electron is canceling out their charges. Here it's canceling them out over here, so it's net 0 for this guy attracting these 2. And then on the other side of the cycle, over when the electron is closer to here, the net charge around here is 0, so he doesn't want to attract them. Still seems like gravity would attract them, and I think that's what's happening now, is they get together, and then they get close, and then when they're close, but the electrons on the outside, they get repelled because their charge is repelling and they're being pulled by the electron on the outside. Let's speed it up. It looks like craziness when you let it go full speed. But when you peer into the electrons, to the atom, there is a pattern. Ooh, wow. Let's go back to the double electron. Okay, back to 2 electrons, 2 protons. Now I got some really weird wobbling behavior that I want to try to reproduce. I need to take out some energy from the system, start it up, expand. So, okay, what's happening? The electron is pulling towards both the protons, and it's getting repelled by that electron. But we have 2 protons closer to this electron. So why is this one not just getting pulled into the both? Well, because this one's also getting pulled into both. And so their steady state is to be exactly this far apart from each other. Speed it up here. And the protons are going into each other because of gravity and their charges that are pressed by the electron, but their own charge wants to repel each other. So you're kind of in an oscillating state. There we go. All I'm doing is changing the time scale when I'm changing this slider. I'm not changing the behavior of the simulation at all. So cool. So what I'm going to do is slow their motion, hopefully when they're on a... Wow, it changed. I didn't change their motion yet. Just changing the time scale. Faster, 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 faster. Sometimes you get the wagon wheel effect, like in old movies. So it looks like the electrons are going slow, but really they're just strobing onto the display. So let me slow it down really a lot. So that's what they're doing. Huh. I, I didn't change. Okay. This is so cool. They've got like a double oscillation back and forth and inside and out. This is so cool. I'm going to stop their motion, start up them again. Let's get them to do something different. Okay, so stop their motion, start them back up. Oh, that's interesting. Let's see what's happening here. So the 2 protons are almost on top of each other. The electrons are in orbit, a strange orbital. If we let it go faster, we can see that they get a full range of motion, but they just get squished into the horizontal plane and then back out again. This is only like one atom. If we had other atoms interacting with this atom, it would just get into double chaos. So we have three body problem here with four particles. You know, 3 body problem extends to 4, 5, 6, 7. But then if we also had 3 molecules or 3 atoms, then it's like another order of chaos on top of chaos. Really cool. Let's see what else we can do. Okay, I'll stop them. So start them back up. Okay, squeeze him a little bit. Oh, wow. Now, okay, this is the wobbling. I can't explain this. I don't know what's happening. Look at that. Wobble, 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 wobble. Why is it doing that? I have no idea. I don't understand that at all. It looks like I have some bug in the program, but I'm not changing the equations. I mean, you're just watching me change the time scale right here. And it's not a wagon wheel effect. And then if I slow it down, you still see the wobble. Okay. That is just such a weird orbit. Does anyone know, are these orbitals in an electron? Like, I know there's SPDF orbitals. Is there an orbital that looks like this actually? Like some kind of cone shaped thing? It's so cool. Turn the fade on. Yep. Now, when it bounces off the wall, you get some behavior that's not exactly true, because you're getting reflected off the wall. And it's preserving energy, but in the middle is really a pure, you know, by itself type of setup. I want to extend the wall, but once um, the electrons really should be much farther from the protons, and I just can't fit it on the screen. So the way I've compensated is to make the Coulomb force not as great as it really should be in reality. But if you just consider that it would do the same thing just on a larger scale, I think you still see basically what's going on. But I will try to change the Coulomb's force to be actual values, from the R universe, and then try to scale the display somehow to show the protons. Oh, also, this proton is rendered much bigger. Same for the electrons. This proton would barely take up a pixel, and fractional parts of a pixel even. Much, much smaller than a pixel. So there's that wobble again. It's so strange. And we get the wobble even when they're not hitting on the sides. See that? I just cannot explain that. Here's some more. I wanted to restart it to get the protons from sticking to each other. I don't know why they were sticking, actually. It seems like they would repel each other. I don't know. Maybe one of them went off the screen. I don't know. I'll have to check their coordinates in the code and do an assert or something if they ever. Or see, what I can sometimes do is alpha blend them, and then you can see that if they're on top of each other, but when they're exactly on top of each other, it doesn't tell you a whole lot. Still, we get the wobble though, so that's what I was mainly concerned about. Let's change them a little. That's good. Huh. So maybe the two protons are at a distance where Coulomb force equals gravity, and so these guys are just stuck along the axis here. It's so neato. Let's change it a little bit. Get one of them bouncing off. Oh, same thing, sort of. Got a little extra component, XY, instead of just along the axis that's normal to both protons. Going a little off in the X direction. And here's the Y direction. Let's change it up a little. Oh, I should speed things up. So cool. There we go. Super fast. Wow. I would have never seen that if I didn't speed it up. So that's slower, faster, 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 faster. Okay, so now the reason this guy's wobbling, the two protons going back and forth, is because the boundary, the electrons that you see here, they're bounced back, so they push off back to get the protons pushing also. If this screen were bigger, here watch, they won't go back anymore. Once the electron interacts with the wall, they push off the wall, which results in the protons pushing away from the wall, even though they don't touch. I guess that's kind of like how real atoms work in our world. You never really touch something, you just repel it from a microscopic distance, atomic scale. Really neat stuff. So cool that this is working. Okay, here's 3 electrons, 3 protons. Seen a lot of weird behavior, so I don't know what's going to happen here, but let's speed it up. Now with 3 protons, I've seen some strange wobbling, like the other wobbles with 2 and 2, they had kind of a 2-point wobble, I would call it. Like here, I've been getting these 3-point wobbles. Maybe because 3 protons create 3 sort of localized gravity wells. I don't know. So if I stop the motion, start it back up, let's make them bounce a little. So when I bounce them, they get off symmetry, so we can start it from kind of fresh. I need to add a randomize button is what I need to do. Something that kind of perturb each particle. So is that the 3-point wobble? Oh, sort of. Still looks like 2 points kind of oscillating back and forth. But I have seen 3, like little triangular wobbles. Let's try to get that working. It's like I'm playing Pong. Boop, 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 boop. Let's speed it up a little. Slow it down. Okay, there's the 3-point wobble, I think. A little bit 3-point, but mostly in a line. But okay, I don't know. It might be 3 points, but in a line, but you can see the time that it slows mid, like, watch my cursor. It goes here, slow down here, here, slow down here, here. But sometimes I see it with my cursor, it goes like here, 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 like a triangle that's moving almost. Sometimes a triangle can be 3 points in a line, though, is what I was describing. I think you kind of see a triangle, little thin triangles. Let's speed it up and see if they change a little. I'm going to change the container to get them to bounce more. Boop. It's hard to get them to bounce in the X direction because they're only going in the Y. What I could do is get them close together, stop their motion, start them back up again. Oh, I know. I'll stop them when they're in the X. There. Start. There we go. Bounce. I was hoping to get some in the Y and some in the X. How to do this? Oh, they have some Y there. There we go. Ooh, there's that wobble. Okay, is that a triangular wobble? Let's slow that down. Or speed it up, actually. Put some fade on it. Yeah, there we go. Fade is nice. I don't know what. I've seen triangular ones. I really want to get that working. My border fades also. Okay, come on, guys. Oh, maybe this will do it. Speed it up. Yeah, that's somewhat of a triangle, but speed it up a lot here. Let's slow down, start it up, bounce it a little. Okay, this will surely add a lot of randomness. Don't want to get the protons stuck together though. I want them to stay separated. So turn off the fade. Let's look at those protons. Here's the alpha blending. See, there's 3 of them. You might have to turn your brightness up on your monitor, but it looks like 2 are kind of stuck together. Oh, maybe that's why I'm only getting mainly 2-point wobbles instead of 3, because 2 of the protons are largely on top of each other. See that? So maybe I should start it over and get the 3 protons apart from each other. Okay, so here's 3, and they're pretty much far apart from each other. So let's see if we can get these electrons to wobble. 3-point wobbles. I need some more energy in this system. Not sure how to get it there though. Oh, there we go. Ooh, wow, look at that. Okay, these guys are, purple protons are behaving strangely because the electrons are bouncing off the walls. Let's just slow down the time increments. Okay, there's definitely 2-point wobbles going on. Let's add some fade. You can see what I mean. Ooh, I think, I don't know. I really saw triangular wobbles earlier. I wish I was recording when that happened. Let's reduce the energy by closing, stopping, and starting it over. That reduces the amount of energy in the system, the movement, the total movement, so they don't hit the walls as much. And let's decrease the time between the time steps. What this gray slider does is it adds a weight, an actual sleep to the simulation, so it's not affecting the step of the simulation at all. It's just affecting how long it waits in between frames. Okay, there's some cool. Huh, wow. That was just changing the fade. I didn't, that was a weird effect. So look at that. These guys are wiggling around. I'm going to leave the fade alone so it doesn't confuse things. Okay, so they're just sitting there, da 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 da, and then one bounces off far away. I guess he comes back, so maybe it's an unstable orbit here. That's what's going on. Yeah, again, it's just the amount of energy for this container even is just too small. So let me stop, reduce the energy, start back up. Wish I could pull one of these protons, just pull it up and see how these guys would wobble. Just trying to get it to do something in get the proton. Oh, there we go. Okay, so what happened was the electrons went out of the bounds of the container. The collision detection is no longer working, so I'll stop, start. Okay, and of course now they have lots of energy. So slow down energy, start it back up. A bigger container. Okay, there we go. This'll work. I guess I'll just play around with this for a few minutes. Electrons are mainly vertical now, so there we go. That was easy enough. Slow it down, see what's going on. Okay, is that? I think those are 3-point wobbles. It's hard to tell because of the box, the container is bouncing. Okay, well, you can see zigzags, which we were always seeing. They're just more pronounced now. Yikes, that's hard to interpret. Okay, what I could do is slow these down. Actually, I'm just slowing the sim down. I'm not slowing the particles down. I'm going to take some energy out. When these guys are far apart, I'm going to stop. And hopefully the electrons are in the center when that happens. So when I start, these guys will still have the energy between them. And these guys won't have as much energy, but outside of them. That kind of helped. Now they're not hitting the wall as much. Oh, wow. That one. Watch this one. He stops. Look at that. He comes over here. Sometimes he just stays there. Maybe it's just chaotic at this point. Not really 3-point triangles, but I do think it's different than the 2-point wobbles with the 2 electrons and the 2 protons. So I'll try to leave it at that. Maybe I'll add 40 protons and 40 electrons next. And I also have neutrons going, so that adds a whole new dimension. Neutrons aren't electrically attracted or repulsed, but they add gravity. Hopefully I caught this. I just got some 3 proton, 3 electron cool behavior. It's neat because the electrons don't have so much energy. Their orbits are closer in, is what I mean. And the protons have a little bit more energy, a little bit more orbit to them. So let's speed it up and see what happens. And the cool thing is they're not hitting the walls. I have to have the walls because so many of these things are just unstable and they go off flying off to infinity and you never see them again. But the walls really affect the simulation, the behavior in the steady state. Once a particle bounces off a wall, you can kind of consider it to be a new particle, that's entering the scene pretty much. It just screws up the orbits, so it's not like it's real anymore. Well, it's real, it's just a different proton, say, or electron coming into the scene. But I like seeing what happens when they aren't interfered by other ones right now. Ooh, there's some wobbling. Let's turn up the fade and see what they're doing. Bounce. Ooh. This one's kind of neat. Once they bounce, their oscillating behavior changes once they bounce off the walls. This currently doesn't do anything. This is left over from my primordial particle system. Maybe I should make these do something for this gravity simulator. These also don't do anything for the gravity simulator, but I could add stuff. These would change the yellow particles. These would change the magenta. Maybe I could change the attractiveness of the Coulomb's charge or the gravity, or change the masses of the particles with these sliders. Phew. Lots of options. It's fun to play creator of my own little universe. Ooh, these guys are definitely wobbling a lot. I think I should do 20 protons, 20 electrons next. And here we go, 20 protons, 20 electrons. I've never done this one before. Glad my simulator's keeping up. Okay, what to do first? Slow it down a little, see if we can see any behavior in these electrons. These electrons are really flying all over the place. We need to reduce energy. Let's bring the container down. And let's stop their motion. And now let's open the container up a little more. Ooh, wow. They're in phase. That's cool. That is really cool. Okay, so they're in phase, but I'm slowing down the simulator a whole lot. Like, these are microseconds that I'm slowing down, so almost 1 millisecond per render I'm sleeping for. So let's speed it up. Ah, cool. Wow, that is so neat. They're all in phase. It's like oh, what is that effect? Quantum entanglement where just making up stuff. With this one electron, he's bouncing. Let me stop. So now he has only this much energy, so he won't be so crazy. Speed up the simulator. Is that a mirror image? Oh, it is. Check out this. Okay, so here's 2 and 1. Now 2 and 1. Yeah, it's the mirror image. That's pretty neat. Am I having a wagon wheel effect too? Or maybe, I guess my sim is just kind of slower because there's so many particles. I want to give it some more energy or some randomness. So let's hit the walls. Bounce a little bit. I really hate the vertical motion when it hits the walls and it doesn't get enough in the other dimension. I really need to add some randomness. Or maybe even better if I could just click in a spot and add a proton or drag a proton around, that would be cool. It looks like there's this quantum foam here. I'm making up stuff again, but check out this blob of electrons. They just kind of the electrons are shape is defined by where the protons are, and they oscillate around, but they're still keeping their shape. Ooh, they hit those sides, so that's cool. Whoa, I've seen a square shape, I guess from the initial container. Yeah, it's got to be what it is. I could add an energy reducer that decreases all velocities by 10%. So that would slow down the particles. And I could add a jitter function that kind of adds random perturbations to every electron and proton. I don't like the square. The square is obviously from the container. I need to add some randomness. See what happens if I do that. Yeah, that's weird. That is so weird. It looks like it's going back and forward in time. So many questions and so many effects remind you of other things that they've looked at in quantum mechanics, like tunneling or spooky interaction at a distance, or even quantum entanglement. I mean, I know it's not, maybe it is, but it just reminds you of everything you've heard of in the news and read about before. So what can we do to add more randomness? I think I need to maybe start over. Huh, that's kind of cool. Bang. We got them all stuck in the middle now. So now they're mainly stuck together. I'm surprised those protons are not getting away from each other. I should add some neutrons, and I think I'll add those two perturbation button and reduce energy button before I get back. Stay tuned.